Hi Bio20, welcome to 2.3, Balancing Matter and Energy. And just quick last little topic, starting out with how the biosphere is an open system where sunlight comes in and heat radiates out into space. We talk about that sunlight energy coming in and increasing productivity. You should know that word as how much vegetation grows in a year. So they look at how much new biomass continues to grow. So not the total, but how much new biomass grows, which means then that if you have a field that continues to get grazed by livestock and regrowing, that would be a much higher productivity than a very lush rainforest because of the regrowth that the field has. So the biomass would continue to increase, so it would have a higher productivity. Homeostasis, of course, is when things are in balance, and we start talking about oxygen and carbon dioxide, where they believe that if there was no life on Earth, the atmosphere might still be 98% carbon dioxide, as they believe it once was, and the ocean's very salty. However, today we only have 0.04% carbon dioxide in our atmosphere, even though we are concerned with the accumulation of that carbon dioxide and in there as one of the major greenhouse gases. It's still a very small percent. How we are finding out historically the amount of those gases is by looking at the fact that microorganisms died, like bacteria, and piled up into sediments, into sedimentary rocks, and those bacteria formed stromatolites. They're a type of sedimentary rocks, and when we look at the banding pattern in there, we can see when there's that certain color. When it has iron, it's kind of reddish. And looking at that, basically the rock evidence, we can see when oxygen levels started to go up, and for a long time the oxygen was trapped in those rocks in stromatolites, but they said as there became more oxygen, then it started to escape and become more like in higher numbers in the atmosphere instead of just being in rocks, which started causing the rise in the amount of it was caused by the increased photosynthesizers that were producing oxygen. And for starters, it was photosynthesizing bacteria that was increasing the oxygen levels. And when we look at this graph, it was first of all a very high amount of carbon dioxide, as we mentioned. As that was dropping over time, we see an increase in oxygen amounts. And so we look at how this balance does involve all of the plants and animals who use each other's waste gases for photosynthesis and cellular respiration. To replicate the Earth's biosphere, there was this Biosphere project. Of course, Earth is number one biosphere, but Biosphere 2 project was saying, let's make something that's like the Earth. So these are really interesting videos to take a look at. This is an actual project that did go on, and they tried to mimic all the biomes on Earth in these different components of this project. And so they thought that if they sealed it off and put this group of people in there, the gases formed, oxygen formed by the plants, could be consumed by all the animals, and it would have a nice balance in there. These are the 8 people who went in there. And as you'll see in the videos, it didn't go so well. There was some incompatibility with amongst the people. They actually started getting hungry, and they, I believe, lasted about 2 years in there. But basically, they could not grow enough food, and they could not get enough oxygen to have a healthy life in the biosphere. So it kind of really didn't fail. However, it taught scientists a lot about the balance that we do have on Earth and how amazing that is. So another project, NASA Houghton Mars project, is happening out in the desert, looking at how we could maybe colonize Mars. So they have a simulation out there, so you can read about that one if you'd like, or take a look at the video. And talking about balance, there are places that are dead zones in lakes where algal blooms have basically algae has used all the oxygen, and it's actually the bacteria decomposing that has taken up all the oxygen. So algal blooms can happen when sewage is basically acting as fertilizer, so the algae starts growing, and it could be because of runoff of like feedlots or fertilizers that goes into the water, and so those algal blooms can, because the bacteria, after decomposing the algae, uses up all the oxygen of the lake. That's why it becomes a dead zone. Wetlands can be filters, and wetlands can also treat sewage. And so in Calcutta, they actually use this interesting balancing effect of when the sewage comes into their large wastewater ponds. They have algae and bacteria that feed on that waste, and then they have fish growing in there, and they have vegetables growing in there, and they basically have a whole little ecosystem that thrives because of the sewage, and basically gets rid of their sewage. And so maybe it's a bit of a controversy as to whether we would want to eat the fish in Calcutta. I don't know. You can make that decision yourself. Okay, so biogeochemical cycles, transferring matter through all those cycles in our biosphere, very important to not disrupt those cycles. We know that the satellites and computer data is just watching and trying to understand and monitor these energy cycles, and make sure that our biosphere on Earth continues to sustain life. There was a last little clip here about the moulins in Greenland, which are these massive holes where there's melting ice, and basically it's causing earthquakes, and the melt, of course, is also causing increasing ocean levels, and it's one of those things that's also being monitored to make sure that our polar ice isn't disappearing and too fast. And so this is just talking about why that is concerning scientists, and that is the last thing that we're going to talk about in chapter 2. So